we've got this problem, the natural log of x squared minus 4 over x plus 8. For a domain problem like this, I personally like to solve the numerator's domain and the denominator separately, finally then bringing all that together for a final answer. So starting with the numerator, we know we cannot take the natural log of a negative answer. So we're going to say that x squared minus 4 must be greater than or equal to 0. When I add 4 to both sides, I'll get that x squared is greater than or equal to 4, with the final result that x must be greater than or equal to 2. I made a serious mistake here, and I need your guys' help. Can you leave a comment below? Tell me what I did wrong. Maybe pause the video and think about it for a bit. Okay, the mistake here is that if you remember, you cannot take the natural log of 0. So in my answer of x is greater than or equal to 2, because I am including 2 as part of that solution, the problem is that when you plug in 2 for x, you'll get that 2 squared minus 4 is 0, and natural log of 0 is undefined. So we need to discard 2 from that inequality. So instead of x is greater than or equal to 2, we must make it x is greater than 2. But I still made yet another mistake, and this one's a little trickier. So think about it, leave a comment, and tell me how I can correct this. Okay, we need to revisit what we did for the numerator for the second mistake. When we were looking for the natural log of x squared minus 4's domain, and we had that x squared must be greater than or equal to 4, simply saying then that x is greater than or equal to 2 isn't enough. Remember, when you take the square root here, it actually produces two inequalities. Either x can be greater than or equal to 2, or x can be less than or equal to negative 2. And if it helps you, sometimes what I like to do when solving something like this is I'll temporarily just make the inequality an equal sign instead, and then change it up at the end. Now, with this in particular, notice that it may not be obvious, but for x is less than or equal to negative 2, if you want to try this out for yourself, you can test your answer by just choosing some value that's less than or equal to negative 2 here. I'm going to choose negative 4. When you plug in negative 4 for x, you're going to get that negative 4 squared is 16, and 16 is greater than or equal to 4. But remember also before moving on that because above we said that you cannot take the natural log of a 0 result, we know that if you plug in either 2 or negative 2 for x here, you're going to get an undefined natural log. So we have to make sure to fix this. And we need to call this x is greater than 2 or x is less than negative 2. So I'm going to put a box around this because the numerator is solved, and we're going to come back to this later. Now for moving on, we're going to work with the denominator. Looking at the original problem here, you've got in the denominator that x plus 8 is what we're working with. Now remember that we can't take the natural log of a negative result, so we're going to again set x plus 8 as greater than or equal to 0. So for this attempt, I'm going to then subtract 8 from both sides of the inequality, leaving me with x is greater than or equal to negative 8. But again, I made another mistake here, and I need your guys' help. Let me know in the comments below on what I did wrong. Okay, here's something that we commonly make as a mistake on our tests. You cannot divide by 0. See, the problem with this inequality is that if you plug in negative 8 for x, you're going to get that negative 8 plus 8 is 0, and dividing by 0 is not allowed. So again, we have to fix this inequality as well. So instead of x is greater than or equal to negative 8, we need to make it x is greater than negative 8. Now that we've done the domain for the numerator and denominator, what I like to do then is bring all of it together and just draw a picture here, because this line graph is going to help me stitch it all in such a way that we get the correct answer. Now for the numerator at the very top, I've shaded the areas of the domain that are included. In other words, they're allowed. Anything outside of that red box is going to be okay. So anything to the left of negative 2 or to the right of 2. Similarly, for the denominator on the bottom, anything outside of the boxes are okay as well. We've got two broken up regions here. One, anything to the right of 2 is okay. But then on the left-hand side, notice that you must be in between those two red boxes, between negative 2 and negative 8. Now, the reason why I drew this huge box for the numerator coming all the way down and cutting through the second line graph is because remember that because we're bringing everything together in our final answer here, anything that's not in the numerator's domain means that they're not allowed in the denominator as well. So the numerator, in other words, has this red box. It's actually restricting the denominator's domain. So I went ahead and drew it all the way down to help you visualize how to find your final answer here. Now, your final answer here is simply going to be all those shaded regions brought together. So think about it, leave a comment below, and tell us how we get the final solution to this problem. Okay, so looking at this, you'll have noticed that we have two things here going on. We have the simpler part, which is everything to the right of the big X, which is X is greater than 2. That part's easy in our final answer. But then to the left, we have to make sure that when we're to the left of the big X, that we're also staying to the right of the X that's at -8. So stitching this all together, you're going to find that you have all values in the set of real numbers where X is either in between -8 and -2. So in other words, -8 is less than X, which is less than -2. Or X is simply greater than 2.